Very good morning, all my dear students, future doctors. Hey, everyone. So, we are going to start with the most amazing lecture, DBE. You know, just like grammar is the backbone of English, so DB is the backbone of isomerism, or you can say organic chemistry. Let's start it, but just before that, do let me know everyone, I'm perfectly audible and visible to all of you. HSP Baba, your HSP Baba on your Unacademy NEET English channel. So kids, do let me know that am I perfectly audible and visible to all of you so that I can start it. But before that, everyone, do let me know that am I perfectly audible and visible to all of you kids? I want to see the Josh. How is the Josh? Just give me the green signal in the chat section so that today's fabulous lecture we are going to start with. And kids, I was waiting, just for this lecture to come so that you should be, you're going to feel very much confident about your organic chemistry once if you have good command on this double bond equivalent. Once again, I'm going to tell you, just like grammar is the backbone of English, just like that, double bond equivalent is the backbone of isomerism. Once you know isomerism, you will say yes. So here is the brief introduction. If you're new to this channel, your HSP Baba teaching chemistry. I'm your chemistry educator on your Unacademy NEET English channel, and I have been teaching for last 23 plus years. So my degree MTech in 2004, and in 99 I was gold medalist at MSc, right? Then GRF and GATE qualified. Kids, after that, if you're new to this channel, do subscribe our channel and hit the like buttons. Kids, what is this? What I can see? So less likes. DB is the backbone of isomerism. Muhammad, and let me thank you from the internal core of my heart for yesterday's lot of wonderful appreciating comments. So really my heart is feeling full of oxygen, the RBCs, red blood cells, by seeing those lovely comments given by you kids. Really mind-blowing, appreciating comments. Really, I'm feeling wonderful. You made my day, that is Sunday, kids. So, Bhumi Kataria ji, welcome. Muhammad, let me see to the comments. Santosh, Sundara. So everyone hit the like buttons. I want to see, sir, can you explain yesterday's homework question? Yes, after telling you this double bond equivalent, after some time, definitely I will explain yesterday's homework also. I'm good, Bhumi Kataria ji. Cherry baby, hello. Mr. Augie, Mr. Augie is also there. The wonderful name. I can see Little Doctor, happy morning, very good morning, very good morning. Sundara Pandyanji. Okay, so everyone, let's start with the double bond equivalent. So let's start, kids. Are you ready? Everyone, are you ready? Show me the thumbs up if you're ready. If everyone is ready, just show me the thumbs up, kids, so that I can understand that yes, everyone is ready. Show me the thumbs up. Hi. Good tag, got tag. Tamilian, Bhumi, yes, everyone is ready. So let's start with double bond equivalent. See kids, let me tell you the names. What are the names? This is known as double bond equivalent. This is known as IHD. This is known as DU. So three names are there. Either we can say double bond equivalent, in short, for double bond equivalent, we are going to write DBE. Or we can say degree of unsaturation, degree of unsaturation. This is another name for the same thing, degree of unsaturation. In shortcut, we can say DU, kids, DU, or we can say index of hydrogen deficiency, index of hydrogen deficiency. Kids, I will let you know the formula, but before telling you the formula, I would like to say that formula never explains the concept. Formula just increases the speed. So before going to the formula, we should understand the concept. Out of these three things, the one thing which you know very well, that is deficiency. Deficiency means something less, just like deficiency of vitamin C, scurvy, vitamin A, night blindness, nyctalopia, xerothalmia, vitamin D, rickets, osteomalacia. So these are the deficiency diseases which are due to vitamins. So they are saying index of hydrogen deficiency. So this is giving you a little bit idea about that what we are going to deal with. That means hydrogen deficiency. If hydrogen deficiency is there, that is going to give degree of unsaturation or double bond equivalent or whatever the thing. Just try to understand. For the very first time, we have studied alkane. Alkane, we know alkane. What is alkane? What is the general molecular formula of alkane, kids? Do let me know. Everyone know CN H2N plus 2. Suppose if I am writing C6H14, that means it is fully saturated. This alkane is fully saturated. What does it mean that fully saturated? It is fully saturated. Fully saturated means it is not having any deficiency with relation to hydrogen. No hydrogen deficiency is there. No hydrogen deficiency is there. No hydrogen molecules, no H2 deficiency is there. No H2 deficiency. What I am saying? H2. This is H2 molecule. No H2 molecule deficiency is there. Now let us suppose, let me take C6H14. So no hydrogen deficiency is there. That means its DU, degree of unsaturation, is 0 because there is no deficiency. Now suppose if I am going to write, kids, C6H12. Now kids, do let me know how many molecules of hydrogens are less in the chat section. If you can see, do let me know how many molecules of hydrogens are less in this compound. How many molecules of hydrogen are less? H2 are less. Kids, do let me know. I'm waiting for your answer. One molecule of hydrogen is less, so its degree of unsaturation is going to be 1. I think you are able to understand. Now kids, do let me know. Suppose if I am taking C6H14, you said its DBE is coming out to be 0. Its DBE is coming out to be 0. So let me consider C6H12. You said its DB is coming out to be 1. Now if I write C6H10, its DB will come out in the chat section. In the chat section, do let me know its DB will come out. Definitely 2. Let me write down C6H8, its DB 3. C6H6, its DB will come out 4. Are you able to understand, kids? Are you getting this point? Everyone hit the like buttons first. Kids, you have seen yesterday's lecture. Now I want to see that Josh, Harshida ji is saying, Harshida Ramesh, that please repeat it again. I will repeat it again, kids, but do let me know. I want to see, yes, your likes. Hit the like buttons, everyone. I want to see that. So, if it is clear to each and everyone, if it is clear to each and everyone, show me the thumbs up again with the hearts for you people that yes, by heart you got it. I will let you know. Vignesh ji, I will let you know. I will let you know each and everything. But before that, do let me know. Now suppose, once again I am telling you, this is one saturated molecule, C6H14. That means there is no H2 molecule deficiency. When there is no H2 molecule deficiency, that means its dBE will come out to be 0. Now if I write C6H6, just subtract, just do the subtraction. You know maths, little bit maths. 14 minus 6, do let me know. 14 minus 6, kids. 14 minus 6, how much is coming? How much is coming? 14 minus 6, 8. So either I can say 8 hydrogen or I can write 4 H2 molecules. Is it correct? Is it correct? So it is having 4 H2 molecules less. That's why its dB is coming out to be 4. Is it clear to all of you? Its dB is coming out to be 4. Now clear? Now, whatever I have told you, I am going to give you formula for that. The formula, the trick, the formula, so that you can find it out immediately. But do let me know if it is clear to all of you. Show me the thumbs up, everyone, if this much is clear to all of you. Now see, formula for dB calculation. Formula for dBE calculation. If molecular formula of compound is given, if molecular formula of compound is given, so see to it, kids. This is the first formula I am going to give you. Formula for dBE calculation if molecular formula of compound is provided. See to it, everyone, see to it. CXH by, where X is the number of carbon atoms, I can write X is the number of carbon atoms and Y is equal to number of hydrogen atoms, So you can write down like this. Now see to it, everyone. The formula for it is dBE is equal to X plus 1 minus Y by 2. This is the formula. Now, no need to go for that subtraction, no need to apply maths. You can apply this formula, you will get the answer. dB is going to come out X plus 1 minus Y by 2. Now, any compounds dB you can find out immediately. Let me show you one example. If this is clear to all of you, let me show you that example. See to it. Everyone see to it. I have given you C6H6. Let's apply this formula. dBE is equal to X plus 1 minus Y by 2. What is the value of X? 6 plus 1. What is the value of Y? 6 by 2. 6 plus 1 is 7 minus 3, that is equal to 4. Clear to all of you? Is it clear to all of you? Are you able to understand? Let me give you one more example. See to it. Everyone see to it. Suppose if I am writing C6H14, we all know very well from the starting that it was having 0 dBE. Just apply the formula. dBE is equal to x plus 1 minus y by 2. So what is the value of x? 6. 6 plus 1 minus what is the value of y? 14. 14 by 2. So 6 plus 1 is 7. 14 by 2 is 7. 7 minus 7 is 0. So let me give you one question for you kids. Try to solve it. Try to solve it. Suppose if I have given formula like C5H10, just find out its dB. What should be its dB? Kids, do let me know. Let me check it out whether you are able to understand or not. I'm waiting for answer, everyone. Hey, everyone. I'm going to see in the chat section, Akash Patil ji is writing 4, minus 4. No, it's not possible. Everyone is writing 1. Rest of others are writing 1. So 1 is being the correct answer. See to it. dBE or du or IHD, whatever you want to say, you can say, that is equal to x plus 1 minus y by 2. So what is the value of x? 5. That is equal to 5 plus 1 minus 10 by 2. 10 by 2. So that is coming out to be 6 minus 5. That is equal to 1. Clear to all of you? Now everyone is able to understand if molecular formula is given. Now kids, if only carbon and hydrogen was given like this, we have got the value of dB. Now by chance, if some kid is saying, ki sir, if along with carbon and hydrogen, oxygen is also given. This I have given if your carbon and hydrogen only. Now if somebody is asking, by chance, along with carbon and hydrogen, oxygen has also provided. Wow, unboxing brothers, 100% you are able to understand. Wow, thank you, thank you. Now see everyone, if along with carbon, hydrogen, oxygen is also provided, see to it. Suppose if the compound is given like this, CX, HY, O, Z, carbon, hydrogen, oxygen, 3 things are provided over there. Then also the formula of dB will remain same. dBE is equal to x plus 1 minus y by 2. That means you can see very clearly whether oxygen is given or not given. dB is not going to change. So what conclusion you can get from here? Oxygen's presence is not going to change dBE. This conclusion we can withdraw from here, that oxygen's presence is not going to change the dBE. Yeah, oxygen's presence is not going to change dBE. Let me tell you kids, suppose if compound is given like this, C6H10, C6H12O, C6H12O. So its dBE will come out, see to it, dBE will come out 6 plus 1, that is x plus 1 minus y by 2, that is 6 plus 1 minus 12 by 2. That is going to come out 7 minus 6, that is going to come out 1. Okay, now see everyone, see to it. Now kids, If any organic compound is given, any organic compound, DBE for any organic compound, DBE for any organic compound, Let us suppose if organic compound is given like this, CX, HYOZ and halogen M and nitrogen, let us suppose N. Okay, so any compound, what they are going to have? Either these or their family members, like halogen's family member, fluorine, chlorine, bromine, iodine, nitrogen's family members, nitrogen, phosphorus, arsenic, antimony, bismuth, or carbon's family member, carbon, silicon, germanium, tin, lead, or oxygen's family member, oxygen, sulfur, selenium, tellurium, polonium. Whatever the elements are given or their family members are given, I am going to tell you its DBE calculation formula. But this is only for top 10 rank. Otherwise, examiner is not going to ask. So this is only for top 10 rank. Now, should I let you know? Kids? Should I let you know? Just to let me know. You want it for top 10 rank? If you want it for, then show me the thumbs up. Then only I am going to tell you. Otherwise, I am not going to tell you. If you want this, show me the thumbs up in the chat section. Then only I am going to show you. Then I am going to tell you. Otherwise, I won't. See, kids. Then the formula will be, DBE formula will be x plus 1 minus h by 2. Once again I am saying x plus 1 minus h by 2. Now kids, you must be asking, what is this h? How to find out h? Now see kids, this h is number of halogen atoms plus number of hydrogen atoms what I am saying, kids, number of halogen atoms plus number of hydrogen atoms minus number of nitrogen atoms. So see, this value of H is equal to number of halogen atoms plus number of hydrogen atoms minus number of nitrogen atoms. Then you can find it out. Kids, you got it? Everyone, do let me know. Everyone, you got it? So, this was the calculation of DBE from the given molecular formula. Now, I am going to tell you how to calculate DBE if any structural formula is given. And then I will let you know the applications of DBE. Kids, are you ready? Everyone ready? Now, second part is calculation of DBE. Calculation of DBE from structural formula. Now see, this question was asked by this very good Bhumi Kataria ji is ready. That is the thing which I always wanted to see in the chat section, that this is the only medium in between me and you, so that I can feel that yes, yeah, Devnath ji, thank you. Kids, like the video, very good. So see, here the DB is equal to dBE is equal to number of cycles, what I am writing, number of cycles plus number of pi bonds, gets number of cycles plus number of pi bonds. What I wrote, calculation of dBE, that is number of cycles plus number of pi bond. Can you see? Number of cycles plus number of pi bonds. Everyone, do let me know. Can you see? Number of cycles plus number of pi bonds. Now see. Suppose if I am writing compound like this, CH2 double bond CH2. How many cycles are there? How many cycles? 0 cycles. So its formula of dB is going to be number of cycles 0, number of pi bond 1. 0 plus 1 is 1. Now let me take another compound. If I say CH triple bond CH. Now kids, do let me know. This was your A compound ethylene. This is your B compound acetylene. What is the dB if you are able to understand? Kids, if you are able to understand, do let me know what is the dB for this compound. Everyone, I want to see in the chat section if you are able to understand. Yeah, very good. That's really awesome. That dBE is going to come out 0 plus 2, that is 2. Now see kids, let me give you some more examples. See to it. If I am going to write compound like this, CH3, CH2, CH2, CH3, what do you think? What's the value of dB? What's the value of dB? Do let me know everyone. What is the value of dB for this compound? Kids, do let me know. What's the dB of this compound? dB, fast, quick, everyone. 0. Now let me write down this compound. Let me write down few more compounds. CH2, double bond CH, CH2, CH3. What's the dB of this compound? CH2, double bond CH, CH, double bond CH2. What's the dB of this compound? Its dB is going to be 1. Its dB is coming out to be 2. Now if I am going to write down compound like this, CH triple bond C, CH2, CH3. What is the dB of this compound? Its dB is going to be 2. Now suppose if I am writing compound like this, CH triple bond C, CH double bond CH2. What is the dB of this compound? 2 and 1, 3. Suppose if I am going to write compound like this, CH triple bond C, C triple bond CH. What is the dB of this compound? 4. Kids, do let me know. Your answer is going to come like this only. If your answer is also like this, do let me know in the chat section. I want to see everyone's answer. Everyone, are you able to understand? Everyone is able to understand. Now kids, let me take one more page. See to it, everyone. Everyone see to it. If I write compound like this is first compound. How many cycles, how many pi bonds? So this compound is having, yes, just do let me know, this compound is having 1 cycle. So 1 plus 0, that is 1. Okay, now let me write down this compound. So kids, this compound, you can see this compound is having 1 cycle plus 1 pi bond. So its dB is going to come out 1 plus 1, that is 2. Now see to it kids, if I am going to write compound like this, just try to find out what should be its dB. So here the dB is going to come out 1 plus 2, that is 3. Now suppose if I am going to write a compound like benzene, kids, do let me know what is the dB for benzene. Benzene is known as C6H6. Kids, this is the resonating structure for benzene. This is the resonating structure for benzene. Sundara Pandyanji, just refresh. From my side, screen is clear. Pandyanji, just refresh it. From my side, screen is clear. Everyone, do let me know. So, here the dB is going to come out. dBe is going to come out 1 ring plus 3 pi bonds. So, total 4. 4 is the correct answer. Now, kids, either you are going to calculate dB with the molecular formula or you are going to calculate dB from the structural formula. Answer is going to come same. Now see, kids, see, everyone see to it. If I am going to give you compound like this, if I am writing C6H6, either I write C6H6 or I draw the compound like this. Compound like this. So that dV is going to come out, okay. That dV is going to come out how much, kids? That dV will come out how much? Do let me know, everyone. Let me calculate. X plus 1 over here, dV is equal to x plus 1 minus y by 2, that is 6 plus 1 minus 6 by 2, that is 7 minus 3, that is 4. So from the molecular formula you can see, very clearly the dV is going to come out, that the answer is, what's the answer, kids? Definitely the answer is 4. Now if I calculate the same dV from structural formula, so how much the dV is going to come out? This is the molecular formula. From the molecular formula we got the dV. Now this is the structural formula. We got the dV. How much the dV is going to come, kids? Do let me know. 1 ring, 1 plus 3, that is also coming out to be 4. If each and everything is clear, do let me know that you got it. Now I am going to give you one interesting question. There you are going to get failed. Should I give you? Veera level. Wow, Santosh ji. Thank you. Should I give you one question where you are going to get failed? Should I give you one question where, that everyone is able to understand? That's really awesome. Very good. Now see, if I am going to give you compound that is known as naphthalene, do let me know what is the dV for this compound. This is known as naphthalene. Just try to calculate what dV you are going to get, kids. dV of this compound. Do let me know. I'm waiting for your answer, kids. This is your naphthalene. Just try to find out the answer of naphthalene's dV. I'm just watching your comments. I'm just sitting in front of the screen. I'm just going through your comments and I want to see whether it is 8 or 7. 50-50. Britannia 50-50. Some of you are writing 7, some of you are writing 8, and 1 or 2 students they are going for 9, kids. Let me check it out. Let me draw it clearly so that you can find out the answer. See to it. How to write down the naphthalene. Naphthalene is like this. See to it. How many rings? 2 rings. 1 ring, 2 ring. And how many pi bonds? Kids? 2 rings. And how many pi bonds? 2 rings plus 1, 2, 3, 4, 5. 5 pi bonds. So what's your answer, kids? What's your answer? Do let me know what answer you're going to get, kids. Do let me know. 2 plus 5, that is 7 is the correct answer. Some of you have written 8, some gone for 7, some gone for 9. Kids, those who have got the correct answer, show me the thumbs up. And those who have got the wrong answer, thumbs down. Thumbs up, thumbs down. Thumbs up, thumbs down. Kids, do let me know so that I can give you one more compound. And let me check it out whether you are going to get the correct answer. If you are able to understand, show me the hearts also for you people only. Now, benzene, naphthalene. After that, I'm going to draw a structure of anthracene. This is your anthracene. See to it. Benzene, naphthalene, this is your anthracene. Then I will show you the magic after that. After that, I will show you the magic of DBE. So calculate its DB. What should be its DB? Do let me know, kids. Once again, I am waiting for your answer. Once again, I'm going to sit in front of the screen and I'm going to check. So Bhumi Kataria ji is getting 10, Aruna Kumari ji is also getting 10, Madhavan Madhu, so everyone is getting 10, Madhavan Madhu 11, Madhavan Madhu ji got 11, Abdul Wahid ji got 11. So once again, what is this? Most of the students, they started for 11, so there is tie in between 10 and 11. So see who is going to win, who is going to win this game. So let me write down anthracene structure. 1 ring, 2 rings, and total 3 rings. How many pi bonds? See to it. 1, 2, 3, 4, 5, 6, 7. 3 plus 7. How much it will come, kids? 1, 2, 3, 4, 5, 6, 7. 3 plus 7, that is 10. So 10 is the winner. Kids, those who have got 10 answers, they are winner, and 11 ones are the loser. Just show me in the chat section who is winner, who is loser. So kids, now another structure. Well-known structure I am going to draw. This is known as, see to it, this is known as structure. See everyone, try to understand. This is known as thalamide. Thalamide. Very well known structure. Its name is thalamide. 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 So could you please let me know what is the DV for this compound? What is the DV for this compound? Everyone, I will wait for your answer. Everyone, do let me know. Everyone, okay, no problem. Abdul Bahid ji, no problem. But for this compound, just do let me know what is the DV for this compound. Bhumi is saying 6. Priyanka, Harshida, Ramesh is going for 6. Kids, rest of others, do let me know. Santosh is going for 7. Oh, everyone is getting different answers. So, kids, oh, everyone's answer is going to be different. So, I have to come for telling you the answer. Let me show you. See, kids, just find out number of rings. Number of rings. Do let me know just for number of rings. Number of rings. Number of rings. Do let me know. How many rings can you see? Do let me know. How many rings can you see? I'm not asking the answer. Just do let me know how many rings can you see. Everyone, please. Everyone has to participate. Otherwise, I won't be able to let you know each and everything with that great concept. Yesterday, you must have seen how much label, how Vera label we have applied. 1 ring. Some are saying 1 ring. There are 2 rings. See, kids. There are 2 rings. 1 ring, this, and this is also 1 ring. You can see this is also 1 ring. If you're not able to see the ring, see to it. There are total 2 rings. Can you see? This is also 1 ring. There are 2 rings. Can you see, kids? Do let me know. 2 rings are there. There are total 2 rings. Can you see, everyone? You got it, 2 rings. Now, if I draw here pi bond, how to draw the pi bond? See to it. I can draw like this. I can draw like this. 1 pi bond, 2 pi bond, 3 pi bond, 1, 2, 3, 4, and 5th pi bond. So 1, 2, 3, 4, 5. Number of pi bonds are 5. Number of pi bonds are 5. So 5 plus 2, how much, kids? Do let me know. 5 plus 2, what you are going to get? 5 plus 2, 7. Once you must know, if you are going to get how to calculate dB, then only I am going to show you the magic. Then only I am going to show you the magic. Now, promise me. Do make a promise that this time you are going to get the correct answer. Then only I can show you the magic. See, everyone. Another question. Another question. CCl, Cl, Cl, C. This is DDT. This is DDT. So if examiner is going to ask, what is the DDT, what is the dBE of DDT? Now I want the correct answer from your side. What is the dBE of DDT? This is dichlorodiphenyl trichloromethane. This is the structure of DDT. So just do let me know what is the dBE of this compound. Now I want to get the correct answer. Everyone, now see, 4 plus 4. 4 plus 4. How 4 plus 4? 2 rings plus 6 pi bond. So that is going to come out 8. 8 is the correct answer. If you got 8, do let me know with thumbs up. If you haven't got 8, how can you please? Benzene is, okay, see. Somebody is asking about benzene. Kids, in detail I will tell you when I am going to tell you about resonance. You can write benzene like this, or you can write benzene's resonating structure like this. However you are going to write benzene's resonating structure, definitely you are going to get 1 ring plus 3 pi bonds. 1 ring plus 3 pi bond. Is it clear? Is it clear to all of you? 1 ring plus 3 pi bonds, whatever the case you are going to write. Now see, last structure I am going to give you, phenolphthalein. Just try to find out dB in phenolphthalein. Phenolphthalein, you know, indicator, phenolphthalein. Phenolphthalein. Now see, I am going to draw the structure of phenolphthalein. This is phenolphthalein, kids. Can you let me know what's the dB of phenolphthalein? Everyone, let me check it out what they are writing in the comment section. It is no, it's not resonating structure, Vignesh ji. Yeah, this is the resonance hybrid of benzene. I will let you know benzene in detail when I am going to tell you about the resonance. But right now, just to let me know, unboxing brother, yeah, you are able to understand each and everything. I can see in the chat section. So some are getting 14, some are getting 13, some are getting 14, some are getting 13. Let me tell you a little bit about benzene. See kids, benzene in detail I will let you know in resonance chapter. These are resonating structures of benzene. These two are resonating structures of benzene, kids. And this is resonance hybrid. Just like you can say the fan, you can see the fan, your fan is having 3 plates, 3 blades. They are, if fan is not moving, you can see 3 plates or 3 blades like this. But when the fan is moving, during its movement, the fans, these 3 plates or 3 blades looks like one disc. These 3 plates, these 3 pi bonds these 3 pi bonds when the fan is in moving condition. I will let you know when I am going to tell you this chapter, then it's looking like this. It will look like one disc. Able to understand? So benzene, whenever somebody is going to talk that how many pi bonds are there in benzene, there are always 3 pi bonds in benzene. Is it clear to all of you? Little doctor, Vignesh ji, everyone, is it clear? If this is clear to each and everyone, okay. Now see, its dB is, so how many total rings? Can you see one benzene? One benzene means 1 plus 3, that is 4. 4 dB. So this is 4, this is 4, and this is 4. Now kids, do remember, this is also one cycle. This is also one cycle. Can you see? Everyone, do let me know. Can you see this is also one cycle? Is it visible to all of you? This is also one cycle. Can you see, everyone? Do let me know. So this is one cycle and these are pi bonds. So one cycle, one pi bond and no other pi bond. So one cycle plus one pi bond. So 4 plus 4 plus 4 plus 1 plus 1 plus 1 plus 1. What I am writing is right or wrong, kids? Do let me know. Is this correct or not? Is this correct or not? Do let me know. 4 cycles plus 10 pi bond, that is 14. 4 plus 4, 8 plus 4, 12, 1, 14 dB. Is it clear to all of you? Answer is going to come out 14 dB. Everyone got it? Everyone got it? Now, kids, should I ask this phenolphthalein is having how many sigma bonds? Can I ask? Phenolphthalein is having how many sigma bonds? Could you please answer it? Could you please answer it? Number of sigma bonds in phenolphthalein. Number of sigma bonds in phenolphthalein. In phenolphthalein, could you please answer it? I am going to love your answer if your answer is found to be correct. I am going to draw the structure. Once Ames asked this question and the structure was not given. But here I am going to give you the structure, but in the examination structure must be missing. Everyone try it out. For the first 3 kids whose answer is correct, I am going to give you chocolate. If your answer is found to be correct, for first 3 students, they are going to get chocolate. Kids, definitely you will get chocolate if your answer is found to be correct. Till now, no one's answer is correct. Kids, till now, no one's answer is correct. Everyone's answer is wrong. Till now, everyone's answer is wrong. Incorrect. Till now, everyone's answer is wrong. Everyone's answer is wrong. Till now, everyone. See kids. See kids. You are not able to count even the number of sigma bonds. See to it. See to it. What happened to you kids? Now see. Everyone see to it. If I am going to ask, this benzene is having how many sigma bonds? See to it. If I ask, benzene is having how many sigma bonds? Do let me know just for benzene. Just for benzene, do let me know how many sigma bonds in benzene. So benzene is having, let me draw this benzene. This is having how many sigma bonds? So see to it. Everyone, see your favorite benzene. You don't know about even benzene. How many sigma bonds are there in benzene? 1, 2, 3, 4, 5, 6. Then 7, 8, 9, 10, 11, 12. So benzene is having 12 sigma. Benzene is having 12 sigma plus 3 pi bonds. So kids, 12 sigma up to here, 12 sigma, then 12 sigma, then 12 sigma. Okay, 12 1 ja 12, 12 2 ja 24, 12 3 ja 36. Now after 36, 37, 38, 39, 40, 41. So the correct answer is 41. Is there anyone whose answer is 41? 41 sigma bonds. Kids, just see to it that today you must have got the awareness about that you are not able to count even the sigma bonds. So kids, did you like it? Did you like it? Do let me know, everyone. Did you like it? Hey kids, did you like it? Everyone, show me in the chat section. I want to see, did you like it? You enjoyed it? And I want to see, hit the like buttons, kids. Hey everyone, if you liked it, really if you liked it, hit the like buttons. I want to see likes to get increased at least up to 90. They should go up to 90, kids. Hey, what I'm saying, that likes are not increasing, kids. Yeah, they started. Okay, Vigneshji, no problem. That's really fantastic. Now, once we got the knowledge of DB, now we are going to see the magic of DB. Now see. Let's see the magic of DB, kids. Let's see the magic of DB. Magic of DB. Magic of DB. See kids, let's see the magic of DB. That we can also say the application of DB. Application or applications of DBE. Applications of DB. So everyone ready? Are you ready, kids? Now we are going to tell you, I'm going to tell you the applications of DB, the magic of DB. Kids, do let me know. Everyone, do let me know. Everyone, do let me know. Okay, so everyone is ready. See, now if I'm provided with, suppose any molecular formula is given like this, C5H10, and the examiner is asking, draw its isomers. Draw the isomers. Draw isomers. Or if examiner is asking how many isomers, either this question or question can be how many isomers are possible. Isomers are possible. This is your question, and options are given like this. See, options are given like this. A option 4, B option 3, C option 2, D option more than 4, more than 4, more than 4. Kids, now if you are going to draw the structures, that is going to take too much time. If you are going to draw the structure, everyone, what I'm saying, if you're going to draw the structure, it is going to take too much time. just use DBE. See kids, just use DBE. Your answer will be very simple. See to it. Could you please let me know? Could you please let me know what is the DBE for this compound? Everyone, could you please let me know what is the DBE of this compound? I want to see your answer in the chat section. Kids, I'm going to make it very simple. No need to draw the structures. I will let you know. 1 dB. 1 dB. So kids, 1 dB is indicating that one cycle is possible. This 1 dB is indicating what hint we are getting from this one. This dB is equal to 1. We are getting one hint that if compound is acyclic, if compound is acyclic means no cycle, acyclic, then one pi bond will be there. Then that compound must be having one pi bond, isn't it? Am I right? Then the compound must be having one pi bond, kids. And if I am going to write cyclic compound, if compound is cyclic, if compound is cyclic, if compound is cyclic, no pi bond, no pi bond. Kids, do let me know, are you able to understand these two things, that if dB is 1, that if compound is acyclic, then it must be having one pi bond, and if the compound is cyclic, no pi bond. Are you able to understand this much? If yes, show me the thumbs up, then I will let you know the magic. I'm going to tell you the magic, how the magic works. Kids, everyone do let me know. Everyone do let me know. Are you able to understand this much? This much is clear to all of you? If yes, show me the thumbs up. Everyone. Hey kids, fast, quick, quick. These two things. If any compounds its dB is, if any compounds dB is equal to 1, we can go to the conclusion like if compound is cyclic, one pi bond. If compound is cyclic, no pi bond will be there. Okay, now see to it, everyone. I'm going to draw C5H10. See, C5H10. C5H10. First of all, I'm going to draw compound like 1, 2, 3, 4, 5, 1 pi bond. 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 Now kids, 1, 2, 3, 4. 4 structures I have written. Now I haven't counted hydrogen. Kids, only where I have given the focus, at which point I have given the focus, what I have considered. Kids, do let me know. I haven't counted number of hydrogens, only I have focused, only I have given importance to what point. I have just counted carbons. I have just counted carbons, number of carbons. I've just counted number of carbons and dBE. Only two things I have considered. I haven't focused on number of hydrogens. No need to count hydrogens. That is going to take too much time. No need to count hydrogen, kids. That is the use. That is the magic. No need to count number of hydrogens. No need to count number of hydrogens. Automatically they will get balanced. Kids, automatically hydrogens will get balanced. Hydrogens will get balanced. Will get balanced. This is the magic. This is the magic. No need to count number of hydrogens. Number of hydrogens automatically, by themselves, by default, they are going to get balanced. Let me show you. Let me show you. Kids, let me show you. See. See. See to it. Carbon, 2 hydrogens, 1 hydrogen, 2 hydrogens, 2 hydrogens, 3 hydrogens. Check it out. How many hydrogens? 2, 3, 5, 2, 7, 3, 10. See, 10. It's coming 10. Automatically they are going to get balanced. See, CH3, CH, CH, CH2, CH3. Just count 3, 1, 4, 5, 2, 7, 3, 10. Automatically they are coming 10. See, CH3, CH3, CH, CH3, they will come out to be 10. CH2, CH3, H, CH2, CH3. So, I'm not going to draw all the structures. One kid is writing, sir, you can write it like that. See, I'm not going to write all these structures. 1, 2, 3, 4. 4, so at least I have got 4. At least I have got 4. Now see, let me draw cyclic. C5H10, 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 cyclic structures. Few of these cyclic structures I am going to write. Cyclic structures, see, cyclic structures. I can take a cycle of 5 carbons. I can take a cycle of 5 carbons. How many carbons I have utilized? How many carbons I have utilized? How many carbons I have utilized, kids? If I am going to write cyclopentane, how many carbons I have utilized? Do let me know, kids. All 5 carbons I have utilized. So its dB is coming out like this. If I am going to write a cycle of 4 carbon, I have utilized 4 carbons. Now let me write down CH3. Now I have utilized all the 5 carbons. Its dB is 1. Its dB is 1. Its dB is also going to come out 1. Its dB is also 1. Now if I am going to draw a compound like this, now see, kids, if I am writing CH2, CH3, its dB is also going to come out 1. Now if I am writing this compound like this, see kids, if I am going to write compound like this, 2-methyl on same carbon, its dB is also coming 1. If I am going to write compound like this, CH3, its dB, 1, 2, 3, 4, 5. At least 5 I have written over there and 4 over there. 9 to I got. So answer is going to come out, kids. What answer you are going to put? That answer is being right. And which options you are going to click for? See, kids, what's your answer? What's your answer? Do let me know in the chat section on which answer you are going to put tick mark. That what's your answer? More than 4. More than 4. More than 4 is the correct answer, kids. D is the correct answer. Now, by chance, if the compound is given like this, see the magic. See the magic. Try to understand the magic. If the question is given like this, see, kids. If question is given like this, C5H8O, number of isomers, total number of isomers possible. Option A is 4, B is 3, C is 5, D is more than 5. What's your answer, kids? If you are able to understand, do let me know. Pyridine, I will let you know. Kids, do let me know. I want to see in the chat section what's your answer for this. if you are able to understand. If you have seen the magic, do let me know what's your answer. Kids, I want to see what's your answer. Yes, everyone. So your answer is going to be D. See why? Just try to find out its dB. Its dB is going to come out how much? Do let me know. Its dB is how much? X plus 1, 5 plus 1 minus y by 2, 8 by 2, 6 minus 4, that is 2. Its dB is coming out 2. That means number of structures are possible. Number of isomers are possible. See how this 2 is indicating that compound can have 2 cycles. Compound may have 2 cycles. Agreed? The compound may have 2 cycles. Or what conclusion we can withdraw from here, kids? It is indicating that compound can have 1 cycle. Compound can have 1 cycle plus 1 pi bond, or it is indicating that compound can be acyclic. Compound can be acyclic with triple bond, or 2 double bonds. Am I right? Kids, do let me know. Am I right or not? Are you able to understand or not? Kids, do let me know that. Are you able to understand or not? So, I can draw number of structures. No need to count for the hydrogens. Now see, 5 carbons, Db2, I can write compound like this. See, kids, 2 cycles. I can write compound like this. 2 cycles, spiro bicyclo. I can write like this. Get see to it. 5 carbon and Db is 2. And 1 oxygen is also there. Oh, 1 oxygen is also there. Oh, 1 oxygen is also there. So I can draw compound like this. Even 5 carbons, I can draw compound like this even. See how many carbons I have taken? 5. Db 1. Oxygen, yes. Db is 2. Let me draw the double bond like this. I can write compound like this. So I have taken 1, 2, 3 carbons. 3 carbons I have taken, and 4 and 5 carbons. I can write like this. Are you getting my point, kids? I can draw number of structures. See to it, everyone. I can draw like this. See, kids. 5 carbons. 1, 2, 3, 4, 5. And 1 pi bond. 1 more pi bond. I can write it like this. Triple bond. 2, 3, 4, 5. I can write like this. No tension of, there is no tension of calculating hydrogen. See to it. Everyone see to it. Exact number they are not going to ask. Kids, exact number they cannot ask. Why? Because this is very lengthy question. Vignesh, they are not going to ask exact number because this is very lengthy question. Now see, let me count the hydrogens. If you want to see, 2 hydrogens, 1 hydrogen, 1 hydrogen, 1 hydrogen, 2 hydrogens. Just count the number of hydrogen. 2, 3, 4, 5, 6, 7, somewhere, yeah, 8. So this is, see, an oxygen, 1 oxygen also. See, kids, I forgot to write oxygen. Let me write down oxygen over here. 1 oxygen was also given. So see, OH Anywhere I can place OH. Now count the number of hydrogens. Everyone count 2, 1, 2, 1 and 1, 2, 3, 4 valency. Now see CH, CH2, CH, CH3. Just count kids. 2, 3, 2, 5, 6, 7, 8. C5, H8, O. Now see over here. 1, 3, 4, 5, 3, 8. C5, H8, O. There is no tension of counting hydrogens. Can you see? There can be many possibilities. See kids, many possibilities. I can write like this 1, 2, 3, 4 and 5, and I can write down OH. I can write down triple bond. See? Whatever I want, I can write. See, even I can write like this 1, 2, 3 and I can write down triple bond, and then I can write CH3 and CH3 1, 2, 3, 4, 5. Whatever I want to write, I can write. Now see, even I can write down like this. Whatever I want to write, I can write it down. Kids, are you able to find that how to answer it? How the magic works? Yeah, that depends on you only. Everyone first do let me know, are you able to understand or not? Kids, first of all, I want to see in the chat section, I think you are able to understand or not. Okay, SMV is writing no clear idea about it. Okay, those who are able to understand first, show me the thumbs up. Then only I will say that yes, DBE is going to help you a lot. Kids, first of all, do let me know. Everyone. Okay, let me tell you. See. One question I am going to give you. Question of AIMS. See, kids. See, application. Fantastic application of DBE. Fantastic application of DBE. Application of DBE. See, kids. Everyone, just do let me know. Are you able to understand or not? Sir, is it our own choice to keep hydrogen for a particular carbon? No. Carbon's valency is 4. So whatever the valency is left, we have to add hydrogens to it. Let me show you. Little doctor. Question is which is not the isomer of CH3, CH2, C double bond OOH. Okay. Now this is going to be the fantastic one. See, everyone. A option CH3, C double bond O, CH2, CH3. B, C, D, CH3, C double bond O, CH2, CH double bond O, no, CH2OH. Now what's your answer, kids? What's your answer? Do let me know what's your answer. Yeah, valency must be satisfied. That carbon's valency is 4, oxygen's valency is 2. Kids, do let me know what's the answer. Now I'm going to show you the fantastic application of DB. Do let me know what's the answer. Kids, I'm waiting. I'm waiting for your answer. Everyone, do let me know what answer you're going to get. Everyone, C. Very good. How you got it? How you got it? Now focus over here. In this compound, we can see very clearly how many carbons? 4 carbons, one thing, 2 oxygens, another thing, and dB is 1. dBA is 1. dB is 1. Just we have to understand these 3 things. Number of carbons, dB, that's all. Now see everyone. Everyone see. In this compound, how many carbons? 1, 2, 3, 4. 4 carbons. Okay. How many oxygens? 1 and 2. 2 oxygens. Okay. Now what is the dB? dB is 1. So definitely it is going to be the isomer. Definitely it is the isomer. In this compound you can see 1, 2, 3, 4 carbon plus 2 oxygens. 1 cycle means dB is 1. dB is 1. So this is also going to be the isomer. Now you can see 1 cycle, 2 cycles. 2 cycles means how much dB? 2 cycles means how much dB is going to come? Kids, do let me know. That means its dB is coming out 2 and that can't be the isomer. Now in this 1 carbon, 2 carbon, 3 carbon, 4 carbon, 1 dB, 2 oxygens, isomer. Are you able to understand? Everyone, do let me know. Are you able to understand? Here dB is coming out 2. So this can't be the isomer because dBe can't be 2. Here dB is 1. Here dB 2. That is not possible. That is not possible. Now kids, do let me know. Now are you able to understand? Are you able to understand, kids? Do let me know. Is it working? Is it working, kids? Are you able to understand? Do let me know in the chat section so that I can say yes, I have explained it, done and dusted. Otherwise, yeah, definitely I will give you. See the magic. One more example I am going to tell you. See the magic. Everyone see the magic. See the magic. If I say which compounds molecular formula is not C6H6, okay? Which compound's molecular formula is not C6H6? Now see to it. I am giving the options. Try to understand. A option, B option, C option, D option, so what's your answer, kids? What's your answer? Little doctor, what's your doubt? Send me once again. Little doctor, what's your doubt, beta? Just do let me know. And everyone else, do let me know the answer. What's your answer? Okay, most majority of the students are going for D. Majority, I can see majority. Santosh ji is going for A, but majority of the students are going for D. So perfect, gets perfect. Your answer is perfect. Just try to understand, just try to focus C6 at 6. If somebody is writing C6 at 6, just find out DBE. Its DBE is 4. That means these compounds DBE is supposed to be 4. If DB is not 4, then they can't be the answer. Then that can't be following the rule. Now see kids, it's one ring over here. Just count, everyone count. How many rings? One ring plus 3 pi bonds. DB is 4. Okay, it's isomer. Here you can see this is carbon, this is carbon, this is carbon. And if you're not able to understand, just do let me know. Carbon's valency is how much? Carbon's valency is how much? 4. So already 2 valencies. How many hydrogens should I add over here? Let me see the doubt. Is it our own choice to keep the number of hydrogens for a particular carbon? No, no, no. This is not our choice. That I'm going to explain. Little doctor, that I'm going to explain. It's not our choice how to keep. Carbon's valency should remain 4. Whatever the valency is less, we have to add number of hydrogens. See, little doctor, see. Everyone see to it. This is how many sticks are there with carbon. See, how many sticks we are having with carbon. Do let me know. 2. So to make it 4, how many hydrogens should I add? Do let me know. To make it 4, how many hydrogens should I add? Kids, do let me know. 2 hydrogens. So I have to add 2 hydrogens. 2 hydrogens. 2 hydrogens. Can you see? Now just check it out. How many rings are there? How many rings are there? There is one ring plus 3 pi bonds. It is also coming out 4. Now see over here, 1 ring, 2 pi bonds, 2 plus 2, this is also coming out 4. Now here, 1 ring, 2 plus 0, this is coming out 2. Its DBE is 2. That is not following the rule. That means this is not the isomer. This is not the isomer, and this is going to be the answer. This is going to be the answer. Kids, now if you want to see the molecular formula, is there anyone who want to see the molecular formula? This will definitely come out to be C6 at 6. This will come out to be C6 at 6. And definitely this is also going to be C6 at 6. But this can never be C6 at 6. If you want to see 5 plus 2, 7 carbons are there. There are 7 carbons. Kids, you got it? You got it? Now if you want to calculate how many hydrogens are there, 2. Little doctor, see to it. If this is carbon, little doctor, focus over here. 2 valencies, this carbon is attached. This carbon is attached. Let me tell you separately. Then you will be able to understand. Little doctor, let me solve your problem. Let me solve your problem. See, if I am writing compound like this compound, see to it, everyone, those who are not able to find out how many hydrogens we are supposed to add. Carbon's valency, carbon valency is how much? Carbon's valency is how much, kids? 4. Now this carbon is attached with how many pi bonds? Your sigma bonds. Or just count how many sticks. Just count how many sticks. 2 sticks. How many hydrogens should I add to make it 4? So I have to add 2 hydrogens. I have to add 2 hydrogens. Now suppose if I am writing carbon like this. Now this carbon is attached with 1 valency. So how many hydrogens should I add? Everyone do let me know how many hydrogens should I add. I am supposed to add 3 hydrogens. 3 hydrogens to make it 4. 3 hydrogens to make it 4. Are you able to understand? Now suppose if I am having compound like this. If I am having compound like this, C double bond C, single bond C, C triple bond C. Now you will be able to understand. See to it, kids. See to it. This carbon is attached with how many valencies? Already attached with 2 valencies. So how many hydrogens should I add? 2 more hydrogens, then it will become 4. Now see this carbon. This carbon is attached with how many valencies? 1, 2, 3. Now how many hydrogens should I add to make it 4? I will add 1 hydrogen to make it 4. Now this carbon is attached with 1 valency, 2 valency. So how many hydrogens should I add? 2 hydrogens should I add? Then it will become 4. Now this carbon is already attached with how many valencies? How many bonds? 1 bond, 2 bond, 3 bond, 4 bonds. So no hydrogens I am going to add because it is already, its valency is already 4. Can you see? Now this carbon 1. Little Dr. G. Everyone do let me know, yaar. Hey kids, do let me know. Now everyone, valency of carbon, are you able to understand? Valency of carbon is clear to all of you or not? Do let me know, kids. And if you liked it, is dV and degree of unsaturation both are same? Yes, friends gaming, that is same. If you see from the beginning, I have told you this thing, that dV means double bond equivalent and degree of unsaturation both are same. Index of hydrogen deficiency. Now just, yeah, that's clear to you, all of you. Now see. Now see, everyone, see to it. Now see to it. Yesterday's homework. Let me explain yesterday's homework. See to it, kids. Yesterday's homework. Analysis I am going to tell you. Analysis of yesterday's homework, kids. See to it. One was, first question was C4H9Cl will have how many structural isomers? This was the question. Kids, right? Now how to do it? Everyone try to understand. Getting answer is not the solution. Just try to see to it how to solve it. How to solve it. Everyone ready? Are you ready, kids? Do let me know, everyone ready? Now see to it. Everyone see to it. Suppose if this chlorine is not there, this chlorine must have attached in place of hydrogen only. So I can write it down that if chlorine is not there, if chlorine is not given over there, it must be like this, C4H10. This is the parent hydrocarbon without chlorine. Are you able to get it? What I am writing, kids? The parent hydrocarbon without chlorine, C4H10. Now kids, C4H10 will have how many structural isomers? Do let me know in the chat section. Do let me know in the chat section. C4H10 will have how many structural isomers? That I have already told you, kids. Do let me know. It will have 2 structural isomers. 2 structural isomers. Is that clear to all of you? 2 structural isomers. It will have definitely 2 structural isomers. What are they? What are they? They are CH3, CH2, CH2 and CH3, N-butane and isobutane. Am I right, kids? Am I right, kids? Yes or no? N-butane and isobutane. This is being N-butane and this is being isobutane. Kids, is it clear to all of you? Now, we must have removed 1 hydrogen to add this chlorine. So, suppose if I am removing 1 hydrogen from here or from here, both will form 1 chlorobutane. Both are going to form 1 chlorobutane. And if I remove hydrogen from here or here, they are going to form 2 chlorobutane. That means from this N-butane, I will get 2 structural isomers like this, one like this and another one like this. So from N-butane, definitely I have got 2 structural isomers. Yes or no, kids? Do let me know. Yes or no? I want to see in the chat section. Kids, I want to see in the chat section. Yes or no, kids? Do let me know. Everyone, I'm waiting for your answer. Isopentane, C4. Oh, ho, ho, ho. 1, 2, 3, 4. Right, right. Thanks. Thanks, kids. Yeah. Thanks, kids. This is isobutane, right? From this, we got 2. Now from this, how many you are going to get? See, if I add chlorine over here or over here or over here, I will get 1. See, anywhere you can write chlorine, CH3, CH, CH3, CH2, Cl. And if I am putting chlorine over here, I will get 1 more. See to it, CH3, CCl, CH3, CH3. So from this, I have got 2. So kids, total how many? And remember that all structural isomers have different IUPAC name. Check it out. All their IUPAC name is being different because structural isomers always have different IUPAC nomenclature. So all their nomenclature is being different. So total I have got 4. So I have got one conclusion. So whenever it is going to come in your examination, like this C4H9Cl, or it is coming C4H9Br, or it is coming like C4H9I, they all will have same answer. What is that? Do remember, C4H9 forms 4 monovalent radicals. 4 monovalent radicals. So their answer will always be 4. Do remember, kids, whether this is given, its answer will be 4. Whether this is given, its answer will be 4. Whether this is given, its answer will be 4. No need to waste time. This is the key point. Do remember always this thing. This is your key point, kids. This is going to be your key point. Always remember this. Are you getting my point, kids? Are you getting my points? So whenever it is going to come in your examination, C4H9, always do remember that C4H9 forms 4 monovalent radical. Always focus over here. It is always going to form 4 monovalent radicals. Kids, are you able to understand or not? Is this point clear to each and everyone or not? Kids, do let me know. What is mean by radical? Let me tell you. Radical means that C4H10, this is what? This is alkane. Name as butane. Now, if I remove one hydrogen from here, if I remove one hydrogen from it, if one hydrogen atom has been removed, then I will write it like this: C4H9 dash. That means this valency must be attached with some atom or group. This means this left valency must be attached with some atom or group. If it is not attached, that means this is not the complete compound. Without adding It is not complete compound. This is partial compound. This is not complete compound. That's why we are going to say it is radical. Radical means not the complete compound. Radical means incomplete compound. Incomplete compound. And how many valency is left? One valency is left. That's why it is known as monovalent. One valency is left. One valency is left. That's why it is known as monovalent. If two valencies are left, divalent. Three, trivalent. Kids, clear? Do let me know. Chlorine, simply chlorine is written, then that is the radical. See, if chlorine is written like this, if simply chlorine is written like this, Cl like this, or Cl like this, or Cl like this, or Cl like this, that means it's not complete. They all are being radicals, chlorine radicals. They all are being radicals. They all are being radical. But if the chlorine is like this, Cl, it's not radical. It is molecule. It's molecule. It's molecule. It's not radical. It's molecule. Suppose if I am writing compound like this, C4H9Cl. This is not radical. This is molecule. Molecule. This is complete compound. This is complete. They are incomplete. That's why they are being radical. They are being incomplete. Their octet or whatever the thing or the charge incomplete. They are being incomplete. That's why they are radical. Clear? Everyone clear? Hey kids, do let me know. Are you able to understand? Is your each and every doubt is getting cleared? Kids, do let me know. Is your each and every doubt is getting cleared or not? Do let me know, kids. Everyone, do let me know. It is for all the atoms. This is valid for all the atoms, not only for chlorine. This thing is valid for all the atoms. If I say any atom, like if I say methyl plus, methyl negative, bromide free radical, bromide negative, anything like this, bromide, it's valid for each and everyone. If I write methyl, then CH3, methyl free radical, it's valid for each and everyone. Kids, are you able to understand? Are you able to understand? Now see the second one, the second homework, second one. C5H11Cl will have how many structural isomers? This was the question. How many structural isomers? This was the question. Okay, kids. Now, if I remove this chlorine, this will become C5H12 alkane. Now, yesterday only I taught you C5H12 alkane will have how many structural isomers? Kids, do let me know. This is going to be the last one. Then I will complete the class, kids. This is going to be the last one because I have already told you I will explain the homework. So this will have, yes, Akanksha Rachi, fantastic. It will have 3 structural isomers. It will have 3 structural isomers. 3 structural isomers, right? Now what are those 3? See to it, kids. N-pentane, CH3, CH2, 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 CH3. This is being N-pentane. Isopentane, CH3, CH3, CH2, CH3, and neopentane, CH3, 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 and CH3. N-pentane, isopentane, and neopentane. Is it clear to all of you? Kids, do let me know, is it clear? One is being N-pentane, N-pentane, isopentane, and this is being neopentane. Kids, now see to it everyone. If I remove hydrogen from this place or this place means same thing. I will get one chloropentane, and if I am removing hydrogen from this position or this position, 2 chloropentane, and if I am removing hydrogen from this position, 3 chloropentane. From N-pentane, how many structural isomers I have got from N-pentane? I have got 1, 2, 3. From this, I have got 3 structural isomers. Are you able to understand? Everyone do let me know. I've got 3 structural isomers from N-pentane. If yes, show me the thumbs up, kids. Kids, hit the like buttons also. Hit the like buttons also, because I want to see the likes up to 100, kids. Before ending the class, before telling you the homework, I want to see the likes must get up to 100. Now see, kids, if I remove hydrogen from here, 1, 2. But kids, you must be saying this is also methyl, this is going to be the same. No, this is different. See, these two methyls are added with CH bond. That methyl is added with CH2. So this is different. This is different from these methyls. So 1, 2, and if I am adding over here 3, and this is different, 4. So we have got 4 structural isomers from here. 4 structural isomers. Now kids, in this neopentane, this methyl, all methyls are same, and this carbon is not having any hydrogen. This carbon is not having any hydrogen. So I will get only 1 structural isomer. Only 1 structural isomer from neopentane. Are you getting my point, kids? Do let me know. Only 1. This question has been asked number of times in various examinations. Directly this question has been asked. How they have asked the question? Neopentane will have how many structural isomers? 100 times they have asked the same question. Neopentane will form how many structural isomers? So on chlorination, this is going to give 1. So total it is coming out, kids, 3 plus 4 plus 1, that is your 8. So always remember C5H11. Always remember, kids. Now no need to do in your exam again and again. Do remember that C5H11 forms how many monovalent radicals? Kids, do let me know. C5H11 forms how many monovalent radicals? Forms 8 monovalent radicals. So kids, at last, wow, Devi Marishwari ji, thank you. Arey, wow, great. Thanks a lot for your words. Now see, whenever you are going to deal with questions in your examination, see the application, what is the benefit, everyone? See, always remember C4H9 will form how many monovalent, and C5H11 will form how many monovalent radicals? Do let me know, kids. These 2 points must always be there in your brain, always in your brain. 4 monovalent radicals, monovalent, and 8 monovalent radicals. So kids, always keep in your brain this point. This point should always remain in your brain, that this is going to form 4 monovalent radical and this is going to form 8 monovalent radical. Then you are going to succeed in your examination within fraction of seconds. Now kids, on next session, in your next session, definitely I will let you know the applications of these 4 and 8 monovalent radical. Definitely they are going to help you in your examination. Kids, is it clear to all of you? Is it clear to all of you? Or should I give you one question? Both are in NCERT. Wow. Now today's question. I'm going to end this session with today's question. Question for the day. Question for the day. Today's question is C4H11N will have how many structural isomers? This is the question, kids. This is your, better to say, what do you call it? Homework. Homework. This is your homework. Right, kids? Priyanka Meherji. So, kids, how was the session? And yeah, Vignesh ji is writing, both are given in NCERT, and that's why they are going to be really important. And here also, there is application of C4H9. If you are going to apply C4H9, that's why I have given this homework. If you are going to apply, just apply C4H9 concept. The question will look like easy. Just apply C4H9 monovalent radical, then you can find out the answer easily. This is the hint I'm going to give you, kids. This is the hint given by me. Just you want to get answer within fraction of seconds, apply this hint and you will get diamond clear. So this session was really awesome and this is going to help you. And don't forget to write it down. Just keep it with yourself and try to make an image in your brain. Just these concepts should not remain in your copy. Try to understand, kids. These concepts should have to go to your hippocampus. Let's try to make it a memory image. They should go in the hippocampus so that people always they are asking, so there is lag. How many times should I remember? How many times should I revise those concepts? These concepts, my kids, these students are not doing regular homework. If students are not doing regular homework, they are always keep on asking that, sir, how many times should I revise? And the students, those who are doing their work regularly on regular basis, they will never ask, sir, I'm lagging, or how many times should I revise? Because try to make it that it should go in your hippocampus. Start doing meditation, reading, then writing. Suppose anything you are not able to keep in your brain, just write it down, because writing makes the thing solidifies. It solidifies the concept. So always try to write it down. If you're forgetting anything, just do revision, proper revision in the morning, so that each and everything should go in the hippocampus and you're not going to forget it. That will remain over there forever and then you can apply it. Kids, bye to all of you. Wow, great, really great. I'm happy to see this. So bye to all of you. Meet soon. I will meet you in next session. That is tomorrow's session, same time, right? That is 11 a.m. in the morning. Bye to all of you, kids. It's your channel only. So do like and subscribe. If you're new to this channel, subscribe it. Otherwise, hit the like buttons. Kids, it's 96. I want to see it 100. Madhavan ji is writing yesterday's question 4 in 1 oic acid. 1 it's your choice whether you write one or skip it. You can write 4 in oic acid or 4 in 1 oic acid. 1 is always understood, whether it is chemistry or maths, 2 की power 1. Power of 2 is 1. Simply you can write 2 power 1 or 2. 3 raised to power 1, that is 3. So simple, it's simple. Now kids, bye to all of you. Little doctors are asking, sir, numbering are necessary. Over here, numbering is not necessary. In this, if we are going to talk about isomerism, just try to find out what are their IUPAC name. If you're not able to find out whether they are structural isomers or not, so you can do the numbering. Otherwise, here numbering is not important. Okay, that's your choice. 2 is left, only 2. So make it 100. Okay. Bye to all of you kids. Meet you soon at 11 a.m. sharp in the morning. Bye to all of you. May God bless you. Bye to all of you. This will not have cycle, Vignesh. If you see the dB, if you apply the formula, no cycle, no dB. dB is coming out to be 0. Vignesh, its dB must be coming out 0, so cyclic is not possible, okay? Cyclic is not possible. Clear?